Hello students, we start the chapter number 2, that is acid, bases and salts. In this chapter, we study about acid, bases and salts. Introduction to this chapter, that is acid and bases plays important role in our lives. Many of our food are acidic. For example, lemon and oranges which contain citric acid, vinegar is a solution of acetic acid. Baking soda is the basic in nature. Acids are sour in taste and change the color of blue litmus to red, whereas the bases are bitter in taste and change the color of red litmus to blue. Acid and bases react together to form another class of compound that is called salt. So, the reaction between acid and base to give salt and water, that is called as neutralization reaction, because in this reaction, acid and bases neutralize each other's effect or to nullify each other's effect. For example, if a person is suffering from problem of acidity due to overeating, it is suggested to take sodium bicarbonate because it neutralizes the excess acid. Thus, in this chapter, we study about the reaction of acid and bases. Learning objective of this chapter are tests to distinguish between acid and bases, acids, bases, strength of acid and bases, solution which and pH scale, measurement of the strength of acidic and basic solution, importance of pH in our everyday life, salts, the pH of salt solution, hydrolysis of salts, preparation of salts, properties of salts, common salt, whereas NaCl or the sodium chloride, caustic soda which is sodium hydroxide NaOH, bleaching powder, calcium oxychloride CaOCl2, baking powder, sodium hydrogen carbonate or the bicarbonate, that is NaHCO3, washing soda, that is sodium carbonate Na2CO3.10H2 or the decahydrate. Next one, water of crystallization. And last point is here, plaster of Paris CaSO4.half H2O, which is called as hemihydrate. In this chapter, we study about the test to distinguish between the acid and bases. First point is here. There are many substances which shows the different color in different medium. Those are called acidic or the basic medium. Such substances are called as indicators. So, the define of indicator is here. The many substances which show different colors in different medium, like one acidic or basic medium, are called indicators. According to their property, the indicator can classified as acid and base indicator which shows different color, olfactory indicators which shows different odor. Types of indicator are here: natural indicator, the indicator which obtained from nature, that are called natural indicators. Like examples, litmus extraction of lichen or the thallophytans group, turmeric, red cabbage leaves, colored petal of flowers like one hydrangea, petunia or the geranium. Next one, synthetic indicators, the indicators which obtained from by the synthesis or the man-made, those are called as synthetic indicators. Phenolphthalein, methyl blue, thymol blue, those are the examples of synthetic indicators. And next one, olfactory indicators, the odor changes in acidic and basic media, like one onion, vanilla essence, and clove oil. So there are few diagrams which shows that the indicators types. First one, litmus solution or the litmus paper. Second, red cabbage, shoe flower, that is hibiscus. Next one, geranium, petunia, onion, turmeric, and clove oil. Those are the examples of indicators. An indicator is a substance that changes its color in acidic or the basic medium. An indicator shows one color in acidic or and a different color in basic media, so that they are called as indicators. Example: litmus and turmeric. Next one, olfactory indicator. An olfactory indicator is a substance whose smell varies depending on whether it is mixed with an acidic and the basic solution. Though olfactory indicators can be used in laboratories to test whether a solution is base or an acid. Onion, clove oil, and vanilla. Universal indicator. An universal indicator is the pH indicator, which is made up solution of several compounds that exhibits several smooth colors changes over a wide range of pH values to indicate the acidity and the alkalinity of solution. A mixture of several indicators that is known as universal indicator. A universal indicator has pH range is from 0 to 14. So which shows the pH scale also. A natural indicator solution has pH is equal to 7. Litmus, which is neutral in medium, that is purple color, in acidic medium that turns into red, and basic medium that turns into blue. Turmeric, which is yellow and neutral medium, when acidic medium they turns no change, and in basic medium that turns into reddish brown. Red cabbage leaves are normally red in color, and in acid medium they have no changes, but in basic medium they has be turned into green color. Flower of hydrangea, which is blue, whenever they turns into pink color in basic media. Phenolphthalein, which is colorless in acidic medium, they have remains colorless, and in basic medium they turns into pink color. Methyl orange, which is orange in neutral medium, whenever dip into acidic medium they turns into red, and in basic medium they turns into yellow. Litmus solution, which is purple color dye, which are obtained from the lichen plants, belongs to the variety of Thallophyta, that is also known as common laboratory indicator, that is also present in litmus strip paper. Students, next one, the acid and bases. Acid are the substances when dissolved in water that dissociates to give H plus or the hydrogen ion, or the H3O plus is the hydronium ion, that are called as acids. That theory is related from Arrhenius. So that one Arrhenius theory, according to simply opposite to there, the bases are, according to Arrhenius theory, when dissolved in water dissociate to give hydroxyl ion or the OH minus ions, which is negative charge ion, either in the acids positive ions only. So those are called acid and bases. According to Bronsted-Lowry theory, Bronsted acids is H plus aqueous ion donor, only and only donor, but the bases, a Bronsted base is H plus aqueous ion acceptor, so only they can gain the ions. Acids are simply we called as which are sour in taste, their pH is lesser than 7, and they turns litmus solution turns into blue to red, and they have no slippery touch or the soapy touch. Those are called as acids. Either while the bases are the better in taste, their pH is greater than 7, litmus solution turns into red to blue opposite to acids, and they are soapy in touch, those are called as bases. Methyl orange, they turns into orange to red and basis turns orange to yellow. Phenolphthalein, that one remain colorless and phenolphthalein colorless to pink. Examples of acids are HCl, H2SO4, HNO3, that one hydrochloric acid, sulfuric acid or the nitric acid. Either while the bases are NaOH, sodium hydroxide, potassium hydroxide, KOH, calcium hydroxide, that is CaOH whole twice. While as acids are sour in taste, they turns blue litmus to red and give H3O ion in the solution that are called acids. HCl, H2SO4 and HNO3 are the example of here. Bases, the bases are bitter in taste and have soapy touch. They turns red litmus to blue and they give hydroxide ion in solution NaOH, KOH. Those are the examples of here. Next one. So the acids, the chemical amount found naturally in plants are derived from the minerals citric acid or the sulfuric acid. They are sour taste of many fruits and the vegetables like one lemon or for instance is due to the various types of acid present in them. The acid word which is derived from the Latin word acidus, that is mean is sour. Uses of acids are manufacture of dye, drugs, paints, fertilizers as food preservatives, in soft drinks and in cooking also. Next one, bases. Bases are oxides and hydroxides of metals soluble in water. Those bases are known as alkalis. Like example, NaOH and CuO, copper oxide. They are bitter in taste and soapy to touch. Seawater and detergents are some examples of bases. So those are basic in nature. Uses of bases are manufacture of shops, soaps, batteries and preparation of motor. Salts. Whenever the acid and base react together to form a new compound, that is salt and water. So salts are the ionic compounds when acid and bases are react together. Example, sodium chloride. Whenever HCl plus NaOH react together, so Na and Cl formed NaCl and HOH, that is water. Zinc chloride, those are another example of salt. Uses of salts are as food preservative in freezing mixture, in cooking food, manufacture of fertilizers, etc. So bases and alkalis. So that one the difference between base and alkalis. Bases undergo the neutralization reaction with acids, but alkalis and the aqueous solution of base, mainly metallic hydroxide. सो सिंपली हम कह सकते हैं जितने भी एल्कालीज हैं वो बेस हैं, लेकिन जितने भी बेस हैं वो एल्कालीज नहीं. We formed as simply a drawing that is denotes that all that is points related from base. And next one, that is alkalis. सो जितने भी बेसिस हैं वो एल्कालीज नहीं हैं, लेकिन जितने भी एल्कालीज हैं वो बेसिस होते हैं. यानी एल्कालीज जितने भी सब्सटेंसेस हैं दोज सब्सटेंसेस आर सॉल्युबल इन वाटर. यानी जितने भी बेस जो वाटर के अंदर सॉल्युबल होते हैं, वाटर के अंदर मिक्स हो सकते हैं, उन्हें हम एल्कालीज कहते हैं. सो BCs are comprises of metal oxide, metal hydroxide, metal carbonate, and the metal bicarbonates. Whereas alkalis, when dissolves, it dissolves in water and dissociates to give OH minus ions. Most of BCs are insoluble in water, but alkalis are soluble in water. All the alkalis are bases, but not all the bases are alkalis. Next one, the point is here, classification of acids. Acid can be classified into 2-3 subgroups that are classification related the based on the strength of acids. First one, strong acids, acids which undergo the complete dissociation in aqueous solution producing a high concentration of H+ ion or the H3O ion are called strong acids. Few examples of strong acids are HCl, HNO3 and H2SO4. Next one, weak acids, acids which undergo the partial dissociation in aqueous solution producing a low concentration of H+ or H3O ions that are called weak acids. H2CO3, H3PO4. So H2CO3 is carbonic acid, H3PO4 is phosphoric acid, HCOH that is formic acid or the methanoic acid, CH3COOH that is acetic acid. Another acids are citric acid, tartric acid. Citric acid and tartric acids are edible form. So some of weak acids are used as an food preservative or used in making foods also. Next one, so weak acids are organic acid also. So अगर हम कह सकते हैं कि एसिड्स को अगर हम और क्लासीफाई करें तो हम कह सकते हैं that one organic and inorganic acids. Organic acids, acids present in fruits and vegetables and naturally occurring substance found in the plants and animals products. Like some examples of vitamin C is ascorbic acid. Another examples are citric acid, which is present in citrus fruits or the orange and lemon, lactic acids, which are sour milk and curd, uric acid, which is present in our urine also. Next one, butyric acid, that is rancid butter. So जो सड़े हुए बटर के अंदर जो भी हमारा एसिड प्रेजेंट है वो ब्यूटारिक एसिड है. टार्ट्रिक एसिड्स, टैमरिंड एंड ग्रेप्स, तो इमली और ग्रेप्स के अंदर जो प्रेजेंट होता है वो टार्ट्रिक एसिड होता है. इसी की वजह से अंगूर भी हमें खट्टे लगते हैं. ओके. नेक्स्ट वन, मैलिक एसिड्स विच इज़ प्रेजेंट इन एप्पल, एप्पी फिज आपने पी होगी. स्टीरिक एसिड्स फैट्स, एसिटिक एसिड्स विनेगर जो है हमें नॉर्मली हम यूज़ लेते हैं काफ़ी सारे चाइनीज़ फूड बनाने के लिए. सो उसके अंदर जो खट्टापन है वही हमारा फूड प्रिजर्वेटिव के रूप में भी यूज़ आ रहा है. इसके अलावा उसके अंदर की वजह से उसका स्वाद या टेस्ट बनता है. टैनिक एसिड्स विच इज प्रेजेंट इन आवर टी, चाय के अंदर हमारा ये टैनिक एसिड्स है. ऑक्जेलिक एसिड विच इज प्रेजेंट इन टोमेटो. बेंजोइक एसिड दैट इज फूड प्रेजेंट इन समवन फूड प्रिजर्वेटिव विच आर used in our sauces, pickles, etc. Hydrochloric acids which is present on our gastric juice in stomach. Some mineral acids or the inorganic acids obtained from minerals that are hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4. सल्फोरस एसिड नाम सुना होगा आपने, लेकिन सल्फोरस और सल्फ्यूरिक में क्या फ़र्क है. सो सल्फ्यूरिक एसिड का हमारा फार्मूला है H2SO4, बट सल्फोरस एसिड का फार्मूला है ROUS. सो सल्फोरस एसिड H2SO3. नेक्स्ट वन, कार्बनिक एसिड H2CO3, फॉस्फोरिक एसिड H3PO4, जो कि हमने अभी भी थोड़ी देर पहले पढ़ा है. ठीक है. नेक्स्ट वन, एसिड के अनदर टाइप्स की बात कर रहे थे हम, दैट इज next one, another type of acid classification based on their concentration of acids. Acid can be classified into two groups. That one, First is dilute and concentrated acids. Concentrated acids, the acids whose acid solution contain high percentage of acid that are called concentrated acid. कंसनट्रेटेड एसिड्स हम नॉर्मली हम कह सकते हैं कि ऐसे एसिड्स जिनको हम अगर टच करें तो हमें बर्न हो जाएगा, नुकसान हो जाएगा, तो ऐसे एसिड्स को हम कंसनट्रेटेड एसिड कह सकते हैं जिनके अंदर वाटर मॉलिक्यूल्स के अमाउंट की वैल्यू बहुत लीस्ट होती है या बहुत कम होती है या नहीं के बराबर होती है. सेकेंड एसिड्स डाइल्यूट एसिड्स जिनके अंदर वाटर मॉलिक्यूल्स की क्वांटिटी ज़्यादा होती है विच इज़ मोर देन द कंसनट्रेटेड एसिड्स. डाइल्यूट एसिड्स भी हमारी स्किन के लिए कोरूड हैं, लेकिन हम कह सकते हैं कि डाइल्यूट एसिड्स जो हैं कंसनट्रेटेड एसिड्स के मुकाबले कम हमें बर्न करेंगे. डाइल्यूट एसिड्स whose acid solution contain a low percentage of acids that are called dilute acids. So few examples are here. HCl, H2SO4 and HNO3 that are strong acids, H2CO3, and someone are here. On the basis of the basicity of acids, so it is the number of replaceable hydrogen ion present in an acid. It is the number of hydrogen or H plus ion produced by the ionization of one molecule of the acid when dissolved in aqueous solution. Those are called basicity of acids. On the basis of basicity of acids, it can be classified into three parts, that is monobasic, dibasic and tribasic acids. मोनोबैसिक एसिड्स जिसमें हाइड्रोजन आयन अगर एक क्वांटिटी में रिलीज होता है तो अपन कह सकते हैं मोनोबैसिक. मोनोबैसिक का एक एग्जांपल अपन फॉर्म करते हैं HCl. HCl के अंदर आप देख सकते हैं, देखिए आप HCl that is formed H plus and Cl minus. सो ओनली यहाँ पर हमारे पास में ओनली एक हाइड्रोजन आयन जो है पूरे मॉलिक्यूल में से निकला है, तो हम कह सकते हैं ये मोनोबैसिस हो गए. अच्छा, नेक्स्ट वन डाइबैसिक. डाइबैसिक का एग्जांपल है H2SO4. सो आप देख सकते हैं हाइड्रोजन की दो वैल्यूज हमारे पास में है, तो H2 प्लस और SO4 माइनस. सो दैट्स वन द एग्जांपल ऑफ डाइबैसिक. अगर जिसमें तीन मॉलिक्यूल्स निकले तो अपन उसको कह सकते हैं दैट इज ट्राइबैसिक. सो ट्राइबैसिक का एक एग्जांपल अपन फॉर्म कर रहे हैं H3PO4. सो H3PO4 के अंदर देखें तो हाइड्रोजन के तीन मॉलिक्यूल्स यहाँ पर रिलीज हो रहे हैं और PO4 का एक ही मॉलिक्यूल हमारा आयन जो है रिलीज हो रहा है, तो जिसमें 3 हाइड्रो H प्लस आयन जो है रिलीज होंगे तो ट्राइबैसिक वैल्यू कहलाएगी. सिमिलरली और बेसिस. So on the basis of acidity, the bases can be classified into monoacidic, dibasic और tribasic. एक मोनोबैसिक का एग्जांपल हम फॉर्म करते हैं NaOH. सो NaOH के अंदर हम अगर फॉर्म कर रहे हैं सो Na प्लस प्लस OH माइनस. सेकेंड वन, द नेक्स्ट एग्जांपल इज हियर डाइबैसिक. डाइबैसिक का एग्जांपल हम फॉर्म करें like one CaOH whole twice. so release करेगा Ca plus and OH minus ions, so which is quantity is 2 molecules. so diacidic base. and the third one, that is tribasic. सो ट्राइबैसिक का हम एग्जांपल फॉर्म कर रहे हैं AlOH होल थ्राइस. सो एग्जांपल इज Al प्लस आयन एंड OH आयन के हमारे 3 आयन जो है रिलीज होते हैं, तो दैट्स वन ट्राई बेसिक. Similarly, the strong bases and weak bases. Next one, strong base. A base which undergoes almost the complete dissociation in aqueous solution, producing high concentration of OH ions. Those are called strong bases. Next one, weak bases. The almost which undergoes almost the partial dissociation in aqueous solution, producing a low concentration of OH ions. Those are called weak bases. Simply here